Hello viewers, welcome back to my channel. Today in this video I am discussing most important concept. This is very useful for many competitive exams like CSR net, KSET, APSET and many MSc entrance as well as government exams also. Which number is greater? I give these some tricks to solve these problems. Which number is greater? Suppose, for example, they given e power of x, e power of pi, or pi power of p. Which number is greater? And root 2 whole power of root 3 or root 3 whole power of root 2. Which number is greater? And root 11 whole power of root 13 or root 13 whole power of root 11. Like this, they asked in the exam. Which number is greater? They asked the which number is greater. uh, now we use the concept to find these like problems, but I give you one simple trick to solve this problem within 5 seconds. This concept is most important, and in KSET also many questions asked these like problems in KSET examinations also. Please watch till the end of the video. I am sure you will get concept. Please watch till the end of the video. I give in finally I give the trick for this concept. In starting I give the proof for this conceptual proof for how this trick is works. Which number is greater? For this I give the conceptual proof. Now we move on to proof. Let f of x is equal to x4 of 1 by x, and this is the domain. X belongs to open equals 0 to infinity. F of x is equal to x4 of 1 by x. This type of sequences is called as pseudo monotonic sequences. Why we call this sequence we called as pseudo monotonic sequence? Because some up to some stages this type of sequences monotonically increasing. After some stage this is monotonically decreasing. That's why we can't conclude this is monotonically increasing or monotonically decreasing. That's why we call as this type of sequences we called as pseudo monotonic sequences. Take the log on both sides. We get log of f of x is equal to 1 by x log x, and taking derivative we get log of f of x is 1 by f of x, and f dash of x is equal to, we take here product rule. We apply the product rule here. 1 by x minus 1 by x square log x, and f dash of x is equal to f of x goes here, f of x, and 1 by x square, we take 1 by x square common, we get 1 minus log x, and f dash of x is equal to f of x means x power of 1 by x, 1 by x square 1 minus log x. Then now for critical points, derivative equal to 0. Now we have to find the critical points of this derivative. F dash of x is equal to 0, and x power of 1 by x square and 1 minus log x is equal to 0, and this is equal to, this is not equal to 0. That's why we take 1 minus log x is equal to 0, and this implies x is equal to e. Now we check x is equal to e is maximum or minimum. We check this is maximum or minimum. For that if f double dash of e, now we have to find the second derivative of the function. F double dash of e is less than 0, that implies maxima. F double dash of e is greater than 0, that implies minima. Now we have to find the second derivative of that function. This is the second derivative. After putting in place of e, in place of x, putting e, we get f double dash of e is less than 0, that implies x is equal to e is maxima. Now we have f dash of x is equal to x power of 1 by x square 1 minus log x. Sign of f dash of x is defined on term 1 minus log x. That's why, because x power of 1 by x square is greater than 0 for all x belongs to open interval 0 to infinity. Here log x is increasing function. As log e is equal to 1, in place of x is taken e. That's why log e is equal to 1. We have log x greater than 1 for all x greater than e, and log x less than 1 for all x belongs to open 0 to e. Therefore f dash of x greater than 0 for all x belongs to open 0 comma e, and f dash of x less than 0 for all x belongs to open e comma infinity. Here we take this as close, this is close, and this is also close e comma infinity. This is the concept of the concept behind this proof for which number is greater. By using this concept we have to prove the which number is greater. This is the note: if f of x is increasing in open 0 comma a closed, that is increasing. If x1 less than x2, then f of x1 is less than f of x2 for all x1 x2 belongs to open 0 comma closed e, and f of x is decreasing in closed e comma infinity. If x1 less than x2, then f of x1 greater than f of x2 for all x1 x2 belongs to closed e comma e. You only remember this note only. We need not to remember this all proof. Only you remember this note. That's enough for exam purpose. This is the important note. For example, we see this. We take root 2 root 3 for all which one of the which number is greater. Now we have to prove which number is greater. See this: root 2 and root 3 belongs to open 0 comma infinity, and root 2 and root 3 always less than e. That's why these two numbers comes in this first interval. That's why f of x is increasing. F of x increasing means if x1 is less than, root 2 is always less than root 3. This implies f of root 2 less than f of root 3, and we know that f of x is equal to x power of 1 by x. Like that we take in place of x root 2 whole power of 1 by root 2 less than root 3 whole power of 1 by root 3. We taken like this, taking power root 2 root 3 on both sides, we get like this: root 2 whole power of root 2 root 3 and less than root 3, this is brackets, root 3 whole power 1 by root 3 power root 2 root 3. Here root 3 get cancelled, root 2 get cancelled. We get root 2 whole power of root 3 less than root 3 whole power of root 2. Here see this: root 3 whole power of root 2 is greater than root 2 root 3. This is the bigger number, this is the smaller number. Like this we prove the maximum questions. We prove by using this concept. In some exams they provide the virtual calculators. By using virtual calculators we use easy to prove these like problems, but in some exams they not given any virtual calculator. For example, KSET like exams, they not given any virtual calculator. That time these problems solving is very tough, but that's why I am giving this trick to solve these like problems. In next video I am solving this type of problems asked in KSET, CSNet and many other examinations. By taking that questions, I try to prove that questions in my next video by using same concept. Thanks for watching. If you like this video, please like, share and subscribe my channel. Thank you.